Hey VSauce, Michael here. The name of the game today specifically is vectors and projectiles. These things are so interesting and there's so much to know. Now, just raw facts. What do we know about vectors? Well, they have both direction and magnitude, meaning that without either direction or magnitude, it's not a vector. You need both to create the vector. There are two parts to a vector. There's the head and the tail. This also means, like direction and magnitude, that without one or the other, it's not a vector. So far, we have 4 specifications for something to be labeled as a vector. That's a lot. But did you know that many things in physics are vectors? Such as displacement, velocity, and even the general idea of force itself. Pretty neat, huh? Now, there are many things in which you can do with vectors, such as measure them by placing them tail to tail and measuring just straight across that line. Measuring head to head, placing them tail to tail, and going straight across. But one thing that I think is cool is that you can take 2 vectors that basically have no meaning, and they're just looking for a purpose in the world. No. You can take 2 vectors and basically just create a third out of thin air. This creates what I generally would like to call a vector triplet. How you do this is with simple algebra. The simplest algebra, really, like ever. It's the Pythagorean theorem. Now, by using the formula a squared plus b squared equals c squared, but replacing a and b with the length of the vectors from head to tail, you can find a third vector, also called, in a right triangle, which is what these would be, the hypotenuse. Mind-blowing, I know, and therefore you are completing the vector triplets. In physics, the main thing that vectors are used and infamous for are free body diagrams. Now, these help determine in which direction and how much force an object is moving with. Let's say you go to the craziest amusement park ever. Imagine the wackiest thing in the entire world. It's coincidentally called Physics Land. You walk in and you go on the very first ride you see. You walk in and you just see a room that spans for what looks like forever because it's Physics Land and anything goes. It's very large, obviously, and it has no air resistance. There's never been air resistance in this specific room since its inception in the creator's mind. Now, obviously, most people would say, bah, it's preposterous. But after being given a brick and a feather, your skepticism flows away, and the reality of this fake physics land comes to be in your mind, and you prove yourself wrong. This is the mysterious place in which free body diagrams refer to. All other forces, such as friction, tension, and even gravity, all exist, but no air resistance. Now back to the main topic, vectors. To truly tie these 2 ideas together, you have to understand what kind of free body diagram we are talking about. Let's say, for the purposes of this conversation, you have a boxcar, one of those cute little Honda Elements, let's say. It accelerates at 20 meters per second. That way. The friction, however, going down because of the asphalt on the road, is 5 meters per second. Gravity, let's say for easier mental math, is going to be 10 meters per second straight down. So you're going to have 20, 5, and 10, creating 15 down. Now that would cause an acceleration of 5 meters per second that way. Pretty cool, huh? And that's how vectors are used. They are used to describe movement for any object at any given point in time. The entire first semester of this physics class that we're in was dedicated to teaching us the ideologies of movement and how it worked with different things. So you can truly see the scope of how important vectors are in physics. I'm Michael. This is VSauce. Thanks for watching.